third activity or third example is to find activity slack. To find activity slack, you must find earliest start and earliest finish, latest start and latest finish. Activity slack is the difference between activity start and earliest start, or activity latest finish and earliest finish. To find ES and EF, you must use a forward process. Okay, to do a forward process, we start with the earliest start of the earliest activity, which start with 0 and end with ES plus T, which is 2. Earliest start of 2 for both, and finish at 5, finish at 6. Okay, when you have two activities that go forward, okay, you are always pick the largest amount to go forward. So earliest start is the largest of the earliest finish of previous activities. Now, to go backward, we are going to do a backward process. Okay, the forward process will give out the highest number, which is completion time. Okay, and for the go backward process, we give out LS and LF. To start LF, you will take the highest number of the forward process and start subtracting number out to become LS. Start subtract number out. When you go backward, when you have two activity that come from the same activity like that, you are going to pick the smallest LS to become the LF of the previous activity. In this case, you picked activity with LS2 or C to become LF for A. Then you get LS0. You must reach at least one activity that has 0 LS. If you do not have at least one activity that has 0 LS, you did it wrong. Okay, with this forward and backward process, we will use this to incorporate with on example 4. Okay, on example 4, okay, we may use extra space, so let me enlarge it. For this activity, example 4, we are going to draw a network diagram first. So the network diagram will start with, so the bigger network diagram is the better, because it will help you identify clear picture. So we can start out by drawing a network diagram. So it's good idea for student to maybe work along with me, so you can make sure that you understand completely. And make sure also that you draw an arrow nicely, so the arrow point to the right direction, because when you go backward, if you don't draw an arrow clearly, you might be confused which activity go first or which activity go last. So it is recommended to draw carefully, like I did. And of course this tool is not pencil and paper, quite hard to control. It's also it's a good time to also review how to draw a network diagram. Okay, when you draw a network diagram, it should come out like that. Okay, first we're gonna start out by using the top area, so I'm gonna maybe change my color to maybe blue. Okay, so I'm gonna use this is my notation. Okay, ES gonna be on the top left, top right will be EF, bottom left will be LS, bottom right will be LF, like that. Okay, so I'm gonna change to maybe a little bit thicker, like blue. I'm gonna use a blue to represent ES. So ES will start with 0, 2, like that, 2, 6, 2, 7. Okay, and then all 6, 8, 6, 7. You can see from activity F that activity F has 2 activity lead to. One is from B and then one from C. To go forward, we're gonna pick the one with the larger, which is 7. Okay, so this G also has 2 activity to go forward. Gonna pick the larger one, which is 8, 11. Okay, for H will be 15, 18, 15, 19, like that. Okay, all activity come down to the last activity. We're gonna pick the one that I think my activity H is the wrong number. change that. Let me change that. So H should be 5. So that will be 20. And to go forward, you have to fix that because otherwise the outcome will be wrong. So at forward, you can see the largest number is 27. We can say that at least the completion time is 27. Okay, now to go backward, I'm going to use maybe black. Okay, to go backward, you have to start out with the largest number as an LS, and then after that you start subtracting amount like that. Okay, now you have two choices over F. The go backward, you're gonna pick the small one. And you have 17 over there. That comes 16. Okay, and then for B you have three choices, 7, 16 and 15, so you're gonna go to the smallest one. Okay, which reach 2. Oh, sorry, not 6. It's gonna be 7. It's gonna be 8. 7, smallest, which is 3, and gonna go with 7, 2, and last one you're gonna pick smallest, 2 and 0. When you end up with 0 like that, means you do it correctly. Okay, as you can see that the next part is, in order to complete, we are going to summarize this into a table. Okay, so we are going to use maybe a small pen. Okay, for activity A, going to be 0, 0. B gonna be 2 and 3. C 2 and 2. D 6, 15. 6 gonna be 16. 7, 7, and 8, 17, and H gonna be 15, 15. I will be 15, 16. J will be 20 and 20. Okay, as you can see that slack can be either a front pair different or the back pair different. Both of them will be the same number. So we're going to be at slack 0, 1, 0, 9, 10, 0, 9, 0, 1, 0. And you can see that which critical critical path will be the path that have zero slack, which should be so in this case critical path will be A, C, F, S, J. Okay, total slack in activity G will be G have slack of 9. Okay, H has slack of 0 and I have slack of 1. Okay, you can see on this activity that the critical path is the path that have zero slack, or both ES and EF or LS and LF have equivalent number. In normal situation, we will highlight the critical path. Okay, so let me highlight the critical path for you. So we have A, C, F, S, J, like that. Okay, so that's it, how you complete the network diagram. Okay. Next exercise, which is exercise number 5, we are going to also experiment on these. Of course we need more space, so let me more space. Okay, you guys go ahead and draw a network diagram to start. So you can start out by drawing a network diagram. Okay, this is gonna be easier, not quite complex. So I'm going to start with start, and with activity A, 7, branch out become B, C, then become D, E, then branch become F and G. Both together go to finish. Okay, so I'm gonna use notation. So I'm gonna use my blue to represent ES, EF. Okay, now let me go start with 0 and 7, 7, 9, 7, 11, 11, 15, 15, 19, 19, 22, okay, 19, 24. So if you have many activities that go to finish like that, we will pick one activity to go backward. One activity that had the largest number will be the activity time that we use to go backward. In this case, we have 22 and 24. We're gonna use 24 to go backward. So I'm gonna go backward with 24, 19, 24, 21. Okay, and you pick the small number to go backward. Okay, once you read 0, you do it correctly. Okay, now let me summarize this for you in a table. Let me change to a small pen. So I'm gonna be 0, 0, 0, 7, 9, 2, 7, 7, 0, 11, 11, 0, 15, 15, 0, 19, 21, 2, 19, 19, 0. Okay, so activity critical will be that. Okay, so critical part will be A, C, D, D, G. And completion time, okay, completion time is gonna be 24. Of course, we will also highlight the critical part. Okay, so that answer question number, forget question number 5. Okay, now next let's go to exercise number 6. Okay, on exercise number 6 is equivalent to exercise on the slide. Okay, I suggest or encourage very much that student try this exercise by yourself and compare the outcome with the slide that you have to see if you can understand the activity onward approach. AOA approach will not be discussed in our class, so don't worry about it. Okay, next example will be example number 7, number 7. Okay, now sorry for the typing. Example number 7 is about assessing risk. When activity faces uncertainty, manager must identify 3 different sets of time to calculate the expected time. So for this activity, we are going to calculate for each activity the expected time by use the formula A plus 4M plus B divided by 6. Okay, so for this activity, we're gonna trying to estimate it. Okay? For example, for optimistic, okay, optimistic, we activity A, okay, T E or the completion time, or let me, for ET or expected time of activity A gonna be, okay, optimistic will be A, most likely M, B will be pessimistic. So we're gonna be 3A plus 4M, 8 times 4 plus B divided by 6, like that. Okay, and then you get the result is 9. And you keep doing that for all activity. You can see, find out that each activity have different expected time. Okay, in order to assess the risk, we use sigma square or variance. For A activity, we're gonna use B, which is 19, okay, minus A is 3 divided by 6, all together square like that. And we find out that it's about 7.11. If you have an Excel is an excellent tool to find out this number. Okay, so that is how you assess the risk or variance and expected time or ET. Okay, and with that in mind, we're gonna first complete for exercise 8. Okay, and sorry for the wrong number. For exercise 8, let me change that. For exercise 8, we are going to start out by finding the expected time. Okay, so I hope I hope you guys maybe pause a little bit to find expected time on your own. Okay, just a reminder, expected time ET equal A plus 4M plus B divided by 6. Okay, risk or variance equal B minus A divided by 6, all together square like that. Okay, so if you find out this, you will get 8, 7.83, 6, 4, 7, and the variance you get 1.36, 0.11, 0.44, and 1.0. Okay, and now the next task is to find out the probability. Okay, as you might see, the result of expected time will be included on the network diagram. So activity A will have 8, B 7.83, C gonna be 6, D will be 4, and E will be 7, like that. Okay, now next step is to find out the completion time. Okay, Okay, so we have AC pause 8 plus 6 is 14. ADE, okay, ADE with 8 plus 4 plus 7 with 19. And then we have activity path BE with about 14.83. As you can see that this activity, the longest part is ADE, which is critical path. Okay, why don't we just highlight it also? Okay, ADE. It's a critical path, and the completion time of this is 19. Okay, with that in mind, we are going to compare the completion time with 21 days for C and with 17 days for D. Okay, so we're gonna go further to the bottom. Okay, in order to find probability, we're gonna use Z equal T minus TE divided by square root of sum sigma square of path. Okay, so in this case we are interested to find out T minus T of ADE divided by square root of sum of sigma square of ADE. So we want to find out whether or not, okay, what probability of ADBE to complete within 21 days. So we're going to find out. We want to test 21 days minus the completion time 19 days divided by sigma square of ADEs, the variance of ADE. So we're going to go up to find the variance of ADE. Okay, variance in ADE will be this amount, A, D, E, added together about 2.44. Okay. Could be 1 plus 0.44 plus 1. Okay. After that, you're gonna find out that Z equal 1.28. Okay, and then after that we're gonna go back to the back package to find out at 1.28. okay, 1.2, let me highlight it. 1.2 is here, 8 is here, so 1.28 is about 0.8997. So we go back. Okay, so meaning that P probability is about 89.97% to complete the ADE in 21 days. Okay, now that is C part. Okay, for D part we want to find out what is the probability of completing the project in 17 days. So we're going to test this. Okay, let me tap a little bit further. Okay, so for D part, we're going to test Z equal T minus T of ADE divided by square root of sum of sigma square of ADE. Okay, remember that these can be any part that you are interested. 17 minus 19, 2.44. Okay, which is about negative 1.28. Okay, when you have a negative number like this, okay, you have to go back to the positive one, as you might recall from your normal distribution or statistic class. Okay, 19 is in the middle. Okay, so 19 is in the center, and as you can see that 22 1 is here. Okay, and these are at Z equal 1.28, and from this point to this point is about 89.97%. Okay, and we are interested in 17 is over here. As you can see that the Z equal over here, Z will equal negative 1.28, which is the opposite side of the positive of Z equal 1.28. As you can recall that if Z equal 1.28, P equal 0.8997, then Z negative 1.28 will be the opposite side of 0.8997, or 1 minus 0.8997, or P is about 10%. So the negative Z value is just 1 minus P of the positive. Okay. And that is the end of the exercise number 8, and please review more example from the slide, and you guys also have more exercises to do on your homework. Okay, in our class we will not discuss about the cost and time trade-off. So this section is going to be the last part of this chapter that students should study. Thank you very much.